Hey there! Welcome to our dedicated series on industrial engineering. In this series, we will discuss diversified elements ranging from IE's early origins and pioneers to futuristic possibilities in motion. Today, the application of industrial engineering is rapidly increasing across the manufacturing and service sector. But this was not always the case in previous decades. Let's dive into the three key early origin elements of IE and how its frameworks have cemented its foundations in becoming one of the top-notch professions around the globe. Even though there are centuries-old examples of early engineering practice and accomplishments, such as the pyramids, the Great Wall of China, and the Roman construction projects, it was not until the 18th century that the first engineering schools appeared in France. The need for greater efficiency in the design and analysis of bridges, roads, and buildings resulted in principles of early engineering concerned primarily with these topics, being taught first in military academies. Military engineering. The application of these principles to non-military or civilian endeavors led to the term civil engineering. Interrelated advancements in the fields of physics and mathematics laid the groundwork for the development and application of mechanical principles. The need for improvements in the design and analysis of materials and devices such as pumps and engines resulted in the emergence of mechanical engineering as a distinct field in the early 19th century. As has been the case with all these fields, industrial engineering developed initially from empirical evidence and understanding, and then from research to develop a more scientific base. Let us now discuss three specific elements associated with the early origins of IE. First element: the Industrial Revolution. There is a general consensus that the empirical roots of the profession date back to the Industrial Revolution, which began in England during the mid-18th century. The driving forces behind these developments were the technological innovations that helped mechanize many traditional manual operations in the textile industry. These include the flying shuttle developed by John Kay in 1733, the spinning jenny invented by James Hargreaves in 1765, and the water frame developed by Richard Arkwright in 1769. Perhaps the most important innovation, however, was the steam engine developed by James Watt in 1765. Second element: specialization of labor. By making steam practical as a power source for a host of applications, Watt's invention freed manufacturers from their reliance on water power, opening up far greater freedom of location and industrial organization. It also provided cheaper power, which led to lower production costs, lower prices, and greatly expanded markets. The concepts presented by Adam Smith in his treatise, The Wealth of Nations, also lie at the foundation of what eventually became the theory and practice of industrial engineering. Examples of these developments include Arkwright's implementation of management control systems to regulate production and the output of factory workers, and the well-organized factory that Watt, together with an associate, Matthew Boulton, built to produce steam engines. Another fascinating component in early origin was exercised by Charles Babbage. He wrote in his book about breaking down the work into small observable units and doing the standardization so an experienced workforce can be arranged for more value-added work. Third element: interchangeability of parts. Last but not the least, another key development in the history of industrial engineering was the concept of interchangeable parts. Prior to the innovation of interchangeable parts, the making of a product was carried out in its entirety by an artisan, who fabricated and fitted each required piece. Under Whitney's system, the individual parts were mass-produced to tolerances tight enough to enable their use in any finished product. This thing eventually became the object of study of Frederick Weyler. So if you have liked the video, then stay tuned for the next video about the pioneers of industrial engineering. In the meantime, if you are an industrial engineering practitioner and interested in any of our internationally accredited training programs, then feel free to check the links in the description below. All of our training is accredited by International Lean Six Sigma Institute England and Exemplar Global USA.